This is Advanced Math, Unit 6, Lesson 7. Double angle proofs. Verify the following. Number 1. Okay, 1 plus cosine 2x equals 2 over 1 plus tangent squared x. Okay, so first recognize that these are the proofs, the verifying where you pick one side and one side only. Since I'm working with double angles and that's the newest thing we've learned, I'm going to pick this side because the cosine 2x is a double angle type problem. 1 plus cosine 2x. Okay, as I've stated before, there's always, when you have cosine 2x, because there's multiple choices, there's always going to be one that's easier. Sometimes you won't notice, you won't recognize, so it's just going to take you a while. Other times you're going to see it right away and, oh, I'm going to use this one or that one. So it just takes practice. What I notice is I have a 1 here in the front, and if I change it to this one, the ones will cancel out. If I do 1 plus and I change cosine 2x to this one here, the ones will cancel out. Let me show you what I mean. So 1 plus, and I'm going to change cosine 2x, I said, to the third one, 2 cosine squared x minus 1. 2 cosine squared x minus 1. And I don't have to worry about distributing a negative because that's a plus sign. All right, combine like terms. 1 plus 1, that's why I picked this one, so they would undo each other. 2 cosine squared x. Okay, now I can see this, and it doesn't look anything like this other than the 2. Okay, so I've talked to you about you can't manipulate this side, but you can at least think about, okay, what would it look like if I did this? So in my head, I would process that. Again, I can't manipulate, I can't change it here, but I can think it through. 2 over Pythagorean's identities back from Unit 5. If you have those notes, or if you don't remember them, you might want to hit pause and look them up. If you have them in your head, you're good. 1 plus tangent squared is secant squared. That's one of our Pythagorean identities. 1 plus tangent squared is secant squared. So is there any way to get this to look like this? Again, I can't put an equal sign here and change it, but I can think it in my head that these two are the same thing. So I can write this as 2 over secant squared x. 2 over secant squared is the same thing as 2 cosine squared, because secant squared and cosine squared are reciprocals of each other, and the 2 stays put. It stays at the numerator of your fraction. Okay, so now I have it where I want it to be. Again, recognizing from my Pythagorean identities that secant squared is 1 plus tangent squared equals 2 over 1 plus tangent squared, and we are done with the proof. We verified that they equal each other. Again, so don't forget, you can do this over here. Again, you can't manipulate it all the way down, but you can think it through to kind of guide you on what you're going to do on this side. Okay, number 2. 1 minus cosine 2x over 1 plus cosine 2x equals tangent squared x. Okay, you can go through and, well, first off, we're going to pick the left side because, again, we're using double angle formulas here, and the left side has cosine 2x in the numerator and the denominator. So, what do I do? Again, I'm running into the same problem I did on the last one. I have 3 possibilities for cosine 2x. Which one do I use? And as I've said before, it technically doesn't matter, but there's always going to be one that allows you to go a little quicker through the problem. So what I recognize here, I said earlier about canceling ones, and I can do the same thing here, but first thing I recognize is that tangent is sine over cosine. So can I get this somehow to be just sines at the top and just cosine at the bottom? So if I wanted just sine at the top, I would use this one here for the numerator. If I wanted just cosine in the denominator, I would use this one here for the denominator. So what is that going to look like? 1 minus parentheses, because I am going to have to distribute that negative. Cosine 2x is going to change to 1 minus 2 sine squared x. I said earlier that was the one I wanted to use. Why this one? Because I'm going to try to end up with just sine in the numerator. And the denominator, 1 plus, I don't need parentheses, but I'm going to put them. 1 plus, and then I'm going to change the cosine 2x to the one that has only cosine. So that's 2 cosine squared x minus 1. Again, it's going to take practice before you realize how to use this, and I'm giving you hints as you go. This one, I realized, hey, the ones will cancel out, that's why I picked it. This one, I'm recognizing, hey, I want sine at the top and cosine at the bottom because I'm trying to get tangent, so that's why I picked these. Again, if you had picked other ones, you'd get it in the end, it's just going to take a little longer. Distribute 1 minus 1 plus 2 sine squared x over 1, and when you distribute the positive, nothing changes. 2 cosine squared x minus 1. 1 and negative 1 cross out, leaving me with 2 sine squared x. 1 and negative cross out, leaving me with the denominator of 2 cosine squared x. And recognizing here that the 2's cross out, they reduce, leaving me with sine squared over cosine squared, which is what? What is sine squared over cosine squared? Indeed, it's tangent squared, which is what I was trying to prove. Tangent squared, and we are done. Okay, so again, it's going to take practice. We'll do some more in class together. I'm going to move on to the next problem. Number 3. Cotangent 2x equals 1/2 cotangent x minus 1/2 tangent x, and double angle, so I'm going to use this one here. Now, we don't have a double angle for cotangent 2x, but we do have a double angle for tangent 2x, remembering that cotangent is the reciprocal of tangent, so it's going to flip on the fraction, not on the negative sign. It's going to flip on the fraction, and we have talked about that before. So cotangent of 2x, when you change it, it's going to be this one flipped around on the fraction. So the 1 minus tangent squared is going to be at the top, and the 2 tangent is going to be at the bottom, 2 tangent x. Okay, one mistake kids make here is they see the 1 minus tangent squared, and they right away say, oh, that's secant squared. No, it's not. Or they will say, oh, it's negative secant squared. No, it's not. I'm going to just put a little thinking bubble here. 1 plus tangent squared x is secant squared x. You cannot change that to a minus. If you do, you have to change both of these, and it would be negative 1 minus tangent squared, which this is not. These two things are not the same. So this is not a Pythagorean identity because of that minus sign. All right. I look at this side as a guide. I have 2 separate terms where here I have only 1. So what are you thinking we can possibly do? Split the fraction. And it's splitting a subtraction, and if I split an addition or subtraction, I have to have a common denominator. So the 2 10x will go on both of them. Again, I know that because I'm splitting, whenever you split an addition or subtraction, there needs to be a common denominator. 1 on the top of this one and tangent squared on the top of the second one. If I were to give you this and ask you to combine this as one fraction, you would write it like this: 1 minus tangent squared over 2 tan x. Okay, some of you can see it right away. I'm going to rewrite it 1/2 times 1 over tangent. You do not have to rewrite it that way, but I'm going to explain why I did. Only because I can see that 1 over tangent is cotangent. So that's why I rewrote it. Some kids can look at this and just say, oh, that's 1/2 cotangent. So if the splitting helps you, split it and rewrite it. If you can look at this and recognize that 1 over tangent is cotangent and the 2 stays at the bottom, it's 1/2, or cotangent x over 2, if you'd like. Minus, the tangents reduce. This is gone, leaving 1 set at the top. So I have tan x over 2, again, as I stated earlier, which is the same as 1/2 tangent x. Okay, so again, if you don't like splitting that, then just recognize that 1 over tangent is cotangent, and the 2 stays at the bottom. Cotangent x over 2 is 1/2 cotangent x. All in all, we end up with what we are trying to prove. It equals 1/2 cotangent x minus 1/2 tangent x. And we are done with these notes.